What if you could grow fresh, healthy produce right in your own home, using just a fraction of the water and space of traditional farming? Stay tuned to learn all about the amazing world of aeroponic farming, and how you can build your very own high-pressure aeroponics system. What if I told you that you could grow food faster with less water and without a single handful of soil? This isn't science fiction, it's a method of cultivation called aeroponics. Imagine a plant, floating in the air. Its roots, naked and exposed, are bathed in a nutrient-rich fog. This is the essence of aeroponics. We remove the soil from the equation, deliver water, deliver minerals, straight to the roots. This cutting-edge technology allows for faster plant growth, higher yields, and significant water savings compared to traditional farming methods. Today, we're going to show you how to build a high-pressure aeroponics system using 30-micron nozzles, cutting water use by 50%. At the very core of a high-performance aeroponics system lies the pump. This is not just any pump, it is the engine that drives the entire process. To achieve the magic of aeroponics, you need a high-pressure pump. Think of it as the system's heart, forcefully pushing the lifeblood of water, nutrients, through the arteries. We're looking for a pump capable of generating a minimum of 80 pounds per square inch of pressure. Emphasize 80 psi, because pressure is the key to creating an exceptionally fine mist. This isn't a gentle rain, it's a dense enveloping fog of incredibly tiny water droplets. The higher the pressure, the smaller the droplets. The goal: droplets around 30 to 50 microns. These minuscule droplets are the secret to aeroponic success. They cling to them. They form a thin, uniform film of moisture across the entire surface of the root hairs. This fine mist also ensures roots have constant access to oxygen, never fully submerged. Compared to traditional soil gardening, where water is lost to evaporation and runoff, aeroponics can reduce water consumption by as much as 90%. Analogy: a high-pressure aeroponic system is like a paint sprayer, atomizing fluid into a fine mist for thin, even coverage with less waste. Now that we have the heart of our system, the high-pressure pump, we need to build the circulatory system. For this, we turn to a humble and versatile material: PVC pipe, specifically 1/2-inch PVC pipe, corresponding PVC fittings. PVC is lightweight, PVC is durable, PVC is inexpensive, PVC is readily available at any hardware store. Cut PVC to length with a simple handsaw. Glue fittings to make a watertight pressurized network, the skeleton of your misting assembly. Layout is critical to ensure every plant gets an equal share of nutrient fog. Build a PVC framework inside the grow chamber beneath the hanging root zone. Install misting nozzles into that framework, tiny orifices that make the spray. Use threaded adapters to connect misters to PVC. Misters must be spaced strategically. Create overlapping cones of mist to cover the entire root zone without dry spots. The flow of nutrients is a simple journey. Pump draws nutrient solution from the reservoir, pressurizes it, and forces it into the PVC network to reach each mister at once. Liquid hits each nozzle and atomizes, exploding into a cloud of 30-micron droplets. After the spray, excess moisture drips is filtered and returns to the reservoir, a closed-loop system. No water is wasted. Ensure all connections are secure and leak-proof. A small leak at 80 psi can make a big mess and drop pressure to your misters. Section 4. The brains of the operation: timers and regulators. If the pump is the heart of your aeroponic system, then the timer is its brain. This simple electronic device holds the most critical responsibility, telling the pump when to turn on, when to turn off. This on-off cycle is not arbitrary. It is the rhythm of life for your plants. They need to be misted frequently enough to stay moist, receive nutrients, but they also need periods of rest. A digital cycle timer is the ideal tool for this job. Unlike a simple 24-hour timer, a cycle timer allows very short and precise intervals. A common starting point is 1 minute on, followed by 5 minutes off, 24 hours a day, 7 days a week. As roots develop, you may shorten the off cycle to meet increased demand for water and nutrients. Alongside the timer, the pressure regulator refines the pump's raw power. It ensures pressure remains constant at your desired level, typically around 80 to 100 psi. Pumps can fluctuate, but the regulator smooths out variations, guaranteeing consistent mist quality. A drop in pressure leads to larger droplets. A spike can stress components. A pressure gauge gives you visual confirmation, a window into the system's inner workings. I was helping a friend set up his first system in his apartment. We completely forgot to double-check the timer settings. Factory default, continuously on. For 2 days, it ran non-stop. Roots nearly drowned. Pump overheated. Section 5. The Cradle of Life. Grow trays, net pots, and substrates. This starts with the grow tray or chamber, a light-proof container that houses the root zone. It can be a large plastic storage tote or a custom-built box. It must be opaque and food-safe. Light is the enemy of roots. It encourages algae, which competes for nutrients and can clog delicate nozzles. Inside this dark, misty chamber, the plants are held in place by net pots, small plastic baskets. A hole in the lid holds the pot snugly. Roots grow down through the mesh into the chamber below. A substrate gives seedlings support, not nutrients. Common choices include clay pellets, leca, or rock wool cubes. Clay pellets allow great air circulation. Rock wool holds a bit of moisture for early stages. You only need a small amount to get started. The lid separates two worlds. Above, leaves bask in light for photosynthesis. Below, roots thrive in a dark, oxygen-rich, misty microclimate. It is a perfectly engineered duality, a true cradle of life. Section 6. A universe in a box, visualizing the flow. To truly understand how these parts come together, let's visualize the entire system as a self-contained universe. At the bottom is the reservoir, the cosmic soup of water and dissolved hydroponic nutrients. The solution travels to the high-pressure pump, the Big Bang, which imbues the fluid with energy to traverse the cosmos of pipes. A pressure regulator fine-tunes the force for a steady push. Now it enters the network of 1/2-inch PVC pipes. The galactic superhighway. At the nozzles, the stream atomizes into a gaseous cloud of microscopic droplets. This is where the magic happens. Roots hang into this nebula. Fine droplets cling to every root hair, delivering water and minerals directly. The cycle timer is the universal clock. 1 minute filled with mist, 5 minutes for humid, oxygen-rich breathing. Excess coalesces and returns to the reservoir through a drain. A tight, efficient, closed loop. It's a miniature water cycle. Simple, elegant, and tuned for explosive plant growth. Section 7. Guardians of the Green. Joining the urban farming frontier, building an aeroponic system is more than a weekend project. It is an invitation to become an active participant in the future of food. This technology, once confined to NASA research labs and large-scale commercial greenhouses, is now accessible to anyone. By assembling these pipes, pumps, timers, you are doing more than just growing lettuce. You are becoming a steward of resources, a guardian of the green, in an increasingly urbanized world. Start small, perhaps a single tote system on your counter. Document your journey, note what works and what doesn't. Observe how roots develop, leaves unfurl, and how quickly you can go from a tiny seedling to a delicious salad. Share your successes and challenges. Connect with online communities of urban farmers and DIY enthusiasts. By building this high-pressure aeroponic system, you'll join a growing community revolutionizing agriculture and reducing environmental footprint. If you enjoyed this video and learned something new, hit like, drop a comment, and subscribe for more on aeroponics, indoor farming, and the future of agriculture. See you in the next video.